Hi, good morning, kids. My name is Jon Dykstra, and I'm a geologist by training. So I have studied rocks all my life. I started collecting them as a kid. I love rocks. And when I moved up to the coast of Maine to live here, I had an interest in the sand on the beaches. I was asking myself, where did the sand on our beaches come from? And as a geologist, I learned that most of the time, what sand is ground up pieces of rock. So you start with a big rock and you have different weathering. You've been studying the weathering processes, both physical and chemical weathering, that breaks down big rocks into smaller pieces. And when they get to the size of about what an ant could carry, that's a sand-sized grain. So that's the sand. So my thinking was that the sand in our beaches come from our local rocks, that the weathering process has broken up the rocks and created the sand in our beaches. And all the rocks down this part of the coast of Maine are basically the same. There's kind of two kinds of rocks. There's a metamorphic, that gray rock that you see, and then there are the granites, the lighter color rocks that you see. So I assumed that the sand would all be the same up and down the coast. Now, and we'll look at a minute at how well I made that prediction. But first, just let's look at some different types of sands. This is a sand from our beach right here in Maine. So that's made up mostly of ground up pieces of quartz coming from granites and things of that sort. But you can get all kinds, different kinds of material that make up sand. They all have, again, that same small grain size, but they can be made up of little animal bodies. They can be made up of like little beads of lava. This is like ground up pieces of limestone. So all different kinds of things that make up sand. But these two right here are from our beaches on the coast of Maine. And take a look at those. Do those two look alike? About the same size, but look at that color difference, huh? Let's see what happens. First of all, I want to show you where I got the sand. So now we're looking, this is the coast of Maine. This is from Google Maps, which is really a cool thing. Take a look at it on your computer. Have your parents show you Google Earth particularly, and you can zoom in on our coastline. We're right here. This is Kennebunkport. Here we are. This goes all the way up to Biddeford. Now, Biddeford Pool is sitting just off here. So this is Goose Rocks Beach right here. And you're coming down through Kennebunkport. This is Wells. Who likes Big Daddy ice cream? I love Big Daddy ice cream. That's right about right there. This is Ogunquit, and then we go down to York. And that's where the goldenrod taffy is. You can see I've got a sweet tooth. But that's down York. So that's the area we're talking about. Here are the different samples where I took sand. I took sand at Goose Rocks. I took sand at two different places at the Kennebunk Beach, at Gooch's and at Mother's Beach, at Wells Beach, at Moody's Beach, at Ogunquit Beach, and I took two samples down here at York, one at Long Sands and one at Short Sands. So this is our collection of sand. And then at home, I've got a really cool microscope that lets me look very closely at rocks and take pictures. So what I did is I mounted these sands on slides, on glass microscope slides, and then I looked at it with my microscope, and this is what I saw. Here are our different rocks, or different sands, and give you an idea of the size. Let me show you. The size of this, the next slide, please, yeah, is about 1/8 of an inch. So it's really small. It's like taking an inch and dividing it into 8 pieces. And every one of these is the same size on the ground. They're looking at 1/8 of an inch. And tell me what you see. I mean, it's a light color here. Oh, say, here's an important piece. We go to the next slide just so we see it. There he goes. So this is the order of the beaches. As I'm driving from north to south, here's Goose Rocks. Here are the two Kennebunk beaches. This is Wells. This is Moody Beach. Look at that. Check that out. Huh? Is that a different looking sand or what? That's Moody. Here's Ogunquit. Here's one York sand, and here's the second York sand. So these are the different sands. And again, do they look alike to you? I was amazed when I first saw it. I expect them to have the same color, to have about the same size of grains, but look at what we see. Really big grains, a lot of yellow sand grains in it. Some more yellow, more yellow. Yellow's pretty gone there. And then this yellow as we're moving north, right, from Moody coming up to Wells, still some yellow. By the time we get to Kennebunk, not very much and very little at Goose Rocks. So it's pretty clear this doesn't come from our local rock, because the rock, again, all the way from Goose Rocks, all the way down to York, basically the same kind of stuff. So what could have caused it? The answer is a glacier. How many people know what a glacier is? It is a very, very big and deep pile of ice. So 20,000 years ago, which seems like a long time. Geologically, it's nothing at all, but that's another story. 20,000 years ago, our coast of Maine, which sits right here, was under a really thick pile of ice, almost 3/4 of a mile thick. That's a lot of ice. So we take a next look at that. Let's see what that ice does. We're looking at here, between these lines, this section right there, what we're going to do is we're cutting the earth and then turning it on its side. This is what geologists call a cross section. So we're looking at this line comes right across the top, and we're looking at vertically down through it. We have this thick layer of ice that's sitting on top of the land. And what it's doing, the way glaciers work, is it snows up here. You get a lot of snow, and then the weight of that snow just pushes this ice sheet. It just oozes out. These little blue arrows are the direction in which that ice sheet moved. As you can see, it's moving from the northwest to the southeast, and this is along that section. And as it goes along the ground, it digs up the top of the ground. It picks up rocks, it picks up sand, it picks up all kinds of stuff, just like a bulldozer. Think of it just that way. Like a bulldozer is just plowing with this big finger of ice, and this whole thick area here is all ground up rock. Let's take one more look at what happens then when it starts to melt. Now this ice has to go away, and so as the climate got warmer, the ice started to retreat. And it didn't grab onto the rock and pull it back. It just left the ground up rock. And that's what forms all this area. Geologists call it till, T-I-L-L. This is glacial till, which is all the ground up rock that got dragged down from Canada and across Maine, and all that different rock is sitting right here left behind. So it was covering this whole part of Maine. What's that till look like? This is a picture of it. There's a tree right here. So this is probably 20, 25 feet or so. But you can see that it's a mixture, right? It's got big chunks of rock. It's got a lot of sand in it. It's got some clay, which are smaller particles. Here's another picture of it. And here's a person standing. Look at the size of that boulder. All kinds of mixed up types of material. So we had that whole layer of this kind of mumbly stuff, and we still have a lot of this around, by the way. In fact, when the farmers first came here, when they were using their plows to dig up the fields, what do you think they found beneath and between the soil? They found these chunks of rock, right? So what do you think they did with those chunks of rock? They put them on wooden sleds, they moved them to the side of their lawn, and they built the rock fences, the side of their farm. They built the rock fences. So those rock fences had at least two purposes. Three. It marked where their property was. It gave a fence to keep their animals in, but most importantly, it gave them a way to get that rock of all this glacial till, get it out of the field so they can plow it and plant their corn and their seeds. So that's a side story on glacial till. But that's why we have so many rock walls in New England, because of all this till. The next slide is going to show us how we go from glacial till to sandy beaches. And this is an important concept. So let's talk about it just a second before we run the video. What waves do, when a wave comes in and it hits a section of glacial till, the energy in a wave is such that it will move a particle the size of a grain sand. So sand a wave can move sand, but the heavier rocks are just that, they're too heavy. So the larger rocks kind of get left behind, and the things that are smaller than sand, clay and silt, get brought up in the water itself, turns the water kind of muddy, and the currents carry it away. So what happens with waves is that the sand is moved, the rocks stay behind, and the clays wash away. And we can actually watch that. You can go to the beach. Next time you're at the beach, I want you to look for this. You can actually watch that happen. So we're going to play a little video. This might take a minute to get where we want it. So you can actually watch this process. So watch when the wave comes in. So here, these little lines here, let's talk about those first. These are the little lines of sand that are getting moved by the wave. Let's watch it actually happen here. Here comes the wave. So here's where the top of the wave was. And if you see that, you see the new, this is the top of that last wave. This is a little line, a little pile of sand that was pushed up by that wave, and then when the wave retreated, it left it. If we can go back and try that again. So in the beginning, you notice so this was the old top. Here's the new top coming up right there, and there's the new top sand as it came in. So that's what waves are doing. Every time you see a wave crash, if it's a peaceful wave and not a storm wave, it is moving the sand forward. When you have a big storm, then the energy profile changes, and the waves will actually scour out the sand and carry it out into deeper water. And then once the storm is gone, for the next couple of months, the waves move the sand back in, and then a storm comes, it washes the sand out, and back and forth the beach goes. If you ever watch that on the beaches, you can see sometimes the sand's really high next to the rocks and the steps, sometimes it's really low. As long as there's enough calm periods between the storms, or non-storm events, the beach is stable. Our concern with climate change is the storms are coming more and more frequently, and there's not enough time between the storms to rebuild the beach. Again, that's another story we'll be talking about sometime. So that's the process. We're taking the glacial till, this unsorted stuff that has big rocks, has sand, and little tiny pieces of silt, and the waves then are concentrated. So on this next slide, this one's a little bit complicated, but I think you guys can get it. Well, we're showing a lot of different things here. This is the slope of the continent. So this is land right here. And sea level was, back when that ice first melted, sea level was 120 meters, almost 600 feet lower than it is today. And as that sea level rose, the sand by the waves kept getting pushed from the lower part of the continental shelf up to where it is today. So as sea level was rising, it was pushing the sand and concentrating the sand from the glacial till. So we had a layer of glacial till, sea level rose, the wave action's concentrating the sand, and it's piling it up and giving us our big beaches. So that's kind of where this sand came from and the process that created it. Let's try a different slide. So now we're back to our samples again, and here we go. And the next one will show us the distance between each of these samples. So there was 5 miles between Goose Rocks and Goochers. This one was pretty close, and that's probably why the sands look pretty similar, right? They're only about 1/8 of a mile apart. Then 5 miles later, we got to Wells. Then 1.6 miles, we got to Moody. So those look pretty close. 2 miles, we got to Ogunquit, pretty different. 5 miles, we got down to Sand here. looking almost more like a gunkwit. And then look at this, just over a half a mile. But look what happened to the sand. Totally different. So what could possibly cause that? Let's take a look. Here were those samples as we were coming south, and right here were those last two. You see how close together they are? That's only 0.7 miles, but do you see something sticking right between it? Let's look closer. There we go. Look at that. We're down in York. Here's a goldenrod right there. We're down in York. This is Short Sands. This is the Nubble Light. This is a big chunk of granite that's sticking out and dividing the currents between the north, which is the Short sands, and the south, which are the sands that came from the glacial till that was down south. And there we got it. We've got this barrier that separated the till from the north from the till from the south. And when the wave action concentrated it, for the next slide, please, we get very, very different sands. So our assumption, now here, so what could be a good hypothesis we could put together to test my theory? What would I have to do? What I think I would have to do is I've got to go further south and take another sample. And if my theory is true, what would you expect? Would it look more like this, or would it look like this? If my theory is true, it ought to look like this, right? It ought to stay without the yellow in it. I haven't done that yet, but we'll take a look at that for the next talk, perhaps. So finally, let's summarize it. We had a glacier, that big pile of ice 20,000 years ago. And about 14,000 years ago, it started to retreat, it started to melt, and it left behind this thick layer of glacial till that had clay, silt, pebbles, cobbles, and boulders, and sand. A lot of sand in that glacial till. Then over the past 2,000 years or so, sea level has been slowly rising. And as it rose, the waves on the beach churned up that till. The smaller particles, clay and silt, were washed away. The heavier particles, the pebbles, cobbles, and boulders, the rocks, heavy rocks, were left behind. And the sand was selectively concentrated. It was moved and built up to create the beautiful beaches we have today. So that's basically the story of how we got here. Thanks for listening. Next slide, thanks for listening. And if you guys have any questions, have your parents or your teachers feel free to email me. I am the Rock Doc, and so the Rock Doc 2020, that's this year, at gmail.com. I would love to hear from you. Any question, no question's a bad question. All questions are good questions. The only bad question is the one you didn't ask. So contact me.